Okay, so we learned about the tangent ratio. Now we want to learn about the sine and cosine ratios. Some people's yard art, go figure. So what exactly are we going to do with the sine and the cosine ratios? Well, if we've got a right triangle, again we have to pick what angle we're going to be at. That affects which one is opposite or which one is adjacent. And if we want the sine ratio, we use the opposite leg over the hypotenuse. If we want the cosine, we use the adjacent leg over the hypotenuse. Notice both sine and cosine use hypotenuse as the denominator. Right? Tangent only use opposite and adjacent. Sine and cosine use hypotenuse. So let's find the sine of angle S, the sine of angle R, the cosine of angle S, and the cosine of angle R. And let's again play both ways. Exact answers of fraction and a decimal approximation. Okay, so sine of angle S. Well, opposite of S looks like 63. The hypotenuse looks like 65. There's my answer. 63 over 65. Or if decimal approximation is requested, there it is as a decimal. Sine of angle R. Well, if I'm at angle R, opposite is now 16. Hypotenuse is still 65. And I can grab a calculator if I want the decimal. Cosine of angle S. Okay, now this time I need the adjacent. So adjacent to S is 16. The hypotenuse is still 65. And then finally, we need to find the cosine of angle R. And if I'm at R, the adjacent side is now 63. Hypotenuse is still 65. And there we go. Now, are you observant? Take a look at something. Interesting. All right. Find the values of x and y using sine and cosine. Write your answers to the nearest tenth. All right, so we got to use decimal approximations. All right, so for x, all right, why am I going to use sine? Well, because for 26 degrees, opposite is x, what we're trying to find. Hypotenuse is what I know. So 14 times the sine of 26 degrees will give me the value of x. Come up with about 6.1. Again, if I use a calculator, I've got to make sure I'm set for degrees. Right? If I'm set for radians, I'll get a very different answer. So the value of x is about 6.1. Now, how about y? Well, this time I'm going to use the cosine ratio because I'm trying to find the adjacent side and I know the hypotenuse. Adjacent over hypotenuse goes with cosine. So the cosine of 26 degrees has to be y over 14. So 14 times the cosine of 26 degrees has to equal y. Come up with about 12.6. Again, with a calculator, make sure you're set for degrees. And the value of y is about 12.6. Find the sine and cosine of a 45-degree angle. How am I going to do that? I don't know any of the sides. Oh, I do. I know the sides. So Bob Ross is going to paint us a... Oh, Bob Ross. No. Let's get a triangle up here. Let's get a triangle up here. Now, if it's a right triangle and one angle is 45 degrees, we know the other angle has to be 45 degrees. And so here is our friendly 45, 45, 90 triangle. All right. So it's a special right triangle. Right? So we know what numbers to use. We can use 1 square root of 2. So pick a 45 degree angle. Doesn't matter which one because we get the same result from either. Sine is opposite over hypotenuse. And if I want an exact value, right, unless the directions tell me to do something else, I want to leave it as a fraction. I want an exact value. Cosine. Well, cosine's adjacent over hypotenuse. Shocking. We get the exact same answer. Isn't that cool? Thank you, special right triangle. That was very special. Okay, so we've introduced sine, cosine, and tangent at this point. So SOHCAHTOA is my memory device. So reminds me that sine is opposite over hypotenuse. Ka reminds me that cosine is adjacent over hypotenuse. TOA reminds me that tangent is opposite over adjacent. SOHCAHTOA. Right? That's a memory device. SOHCAHTOA. And no, let's get that out of here. Let's get something more desirable to look at. Okay, so we're gonna have a worksheet. And then on IXL, we're going to get into the trig ratios for sine, cosine, and tangent. And again, some people's yard art and some people's houses, go figure.